Okay, cool. Well, thank you everyone for coming. I was expecting to be speaking to a completely empty room, being at 9:30 on a Friday with the party last night. So thank you very much for turning up, and hopefully this will be fairly gentle for first thing. It's not going to be too much really hardcore technical stuff, just some interesting ideas. So my name is Ian Barber. I'm a developer advocate for Google, and I work as part of the Google Plus developer relations team. So I talk about Google Plus and Google Plus sign-in and various things all the time. And today I wanted to talk about using Google Plus sign-in on Android and iOS, but I don't just want to talk about that in general. I want to talk about the idea of sign-in, why I think it's important, and why I think Google Plus sign-in is something you should consider. I think sign-in is one of the things that you can do that will make the most difference to your application. It's one of the areas where you can get the most bang for your buck in terms of investing time in it. And a lot of the reason for that is going to be specific to your application. It's going to be specific to the stuff you work on. You're going to have things in there which benefit from knowing who the user is and having that consistent identity. But there are some things which are kind of universal. And one of them is this problem. The problem that all of us here right now have, I'm sure, more than one screen on them. And most people have more than one screen. There was a bit of research internally at Google the other day I saw, and it was just trying to show when people use things like tablets and phones and other devices throughout the day. And it said, when do they consume content? And the thing I really took away from it was that people use all of them all the time. There was never a dead period. I was expecting, well, maybe people don't use PCs at certain times during the day. Maybe that's just a work thing. No, throughout the day, all of these devices, all of these platforms are popular. And I think that's not going to go away. We had this kind of viewpoint that you were going to have phones and then tablets, and these things are just going to surpass laptops, and we'll get rid of those extra platforms. I don't think that's true. I think we're just going to add more and more. We have things like smartwatches and glass, and fundamentally, it's incredibly easy to put an application platform into almost anything these days. You can do it with, $30, $40 worth of hardware. You can build something that could run, say, Android apps. So we're going to see more and more platforms, and that makes understanding what we're doing a lot harder. Users are going to use our stuff across lots of different devices, and when they use it, they're going to not use it in the same way. It's not like we're going to see the same behavior go from one to another. So if we want to understand what's going on with our users, if we want to understand what's going on with our apps, we need to have some way of joining that together. That was very much the idea behind what the analytics team did. I think this was I/O, they started talking about this, which is universal analytics. And the idea is you can do something like have a single identifier so that you can track a user who might research something on their mobile phone, who might do some price comparison on their desktop PC, and who might come and make a purchase in store. Someone that's gone through that flow is a valuable customer. But if you don't know where they've done the research and you're only looking at where they made the purchase, you're going to spend your money and, more importantly, your time in the wrong place. You're going to spend your effort optimizing something which isn't actually where the user is. So this is a really great tool. Universal Analytics is a really great tool for letting you bring together analytics across platforms. But one of the things that can really help with it is having a way of identifying the user. If you know who the user is on all of these different environments, you can much more easily pull together this information and get a real view of who you're dealing with, who you're talking to, and how they're using your product. And the easiest way to get that user ID is to have the user sign in. If the user identifies themselves to you and you give them back a better experience for that, then you benefit a lot by having an application which you can genuinely make better, you can genuinely improve. So that's true of any sign-in, right? If you just go and implement username and password, as long as you can get the user to sign in, you get that benefit. And I think that social sign-in and Google Plus sign-in in particular has 3 reasons that you should consider it, 3 reasons that it is fundamentally a better choice and can let you do more things. And I think these are the 3, because I think it lets you make your apps better, it lets users get signed in and stay signed in, so it's a lot faster for them. And I think it's stronger. And when I say stronger, I mean in terms of security. When we're talking about sign-in, we often think of username and password. And I hope everyone has, at this point, heard the message that passwords are maybe not the best thing for you. Passwords are fundamentally risky. If you're storing passwords right now, you're thinking, okay, I've got to salt and hash these, and I've got to put them into my database. But if you want to be secure, you need to be thinking about how are those passwords getting transported? Where is the plain text version of that password going? Is it unencrypted as it moves across the network? Is it ever hitting disk? Is it ever getting logged? Is the encrypted version ever getting logged? Is there any way to work that out? Like, you have to think about the whole chain of security. And that's tough. And the reason you have to think about it is because it is a target. If you look at any of the stories of people getting hacked, you know, these journalists getting hacked, people like that, you will see that what happens is a vulnerable system is broken into, and they escalate onto a less vulnerable system. And that is a very, very common pattern. The security of a user on your system with a username and a password is the same as the weakest place they have used that username and password. If they use email address to log in and they write a terrible password into some awful site that stores it in plain text, and they use that same password in your app or on your site, that's a risk. Someone can hack that site and then get into yours. And it also could be that they could hack your site, not because they have any interest in it, but because they want to escalate to another. Passwords are they inherently carry that risk because they are something that is naturally insecure. They've got to be memorable, but you've got to deal with them. So there's things you can do to improve it. You can do things like two-factor authentication. So you send an SMS as well as recording the password. So you're proving that the user has that device, they have that phone. You can do things like heuristics to detect, is this account in a risky state? You know, am I logging in from here and from the US at the same time? If I am, something weird is going on, or I'm on a VPN. But something weird is probably going on. And this is the kind of things that the security teams at Google spend a lot of time doing. It's the kind of things that the security teams at the other big social login providers spent a lot of time doing. And that is why they can run passwords. And I kind of think you guys probably shouldn't most of the time. Of course, there are cases where you do have security teams, or financial services and banks, and that's absolutely fine. But it should be that level of diligence. Now, not having passwords doesn't mean not owning the user, not having user login. Totally fine to keep an email address. And in fact, that gives you a way out. You know, if I come as a user to your application, and for whatever reason I've deleted my Google account and I was using Google Plus sign-in, I should still be able to get in. But you can do that with a forgot password type flow. Send me an email, let me click it, let me sign in, and I'm there. You don't have to store passwords in order to do that. So, brief security rant over. I'm sure not many people are going to go and delete their password database because of this, but do think about whether you're getting value for the cost of the actual care and attention you have to pay for passwords. I think social sign-in is faster, right? This is one of the reasons for doing it, is because I can click and I get a consent dialog and then I'm signed in. I don't have to go through and fill a form, I don't have to make a password up, I don't have to verify my email address. That's valuable. That's what we want to take advantage of, right? It should be simpler for the user and faster. But Google Plus sign-in aims to be faster in another way, in that once the user has signed in, we really don't want them to have to sign in again. The view we have of identity is that it's a service. It's like on a browser or in a mobile application when you want to access location. When you access location, a bar comes down or an alert pops up and says, hey, this app would like to access your location. You say, OK. You've granted it access, and then it continues to have access. This is how we view identity. When an application wants to get access to your identity, when it wants to sign in, it requests you have to give it consent, and then once you have done, why should you have to give it again? So we want to make it so that you do not have to reconsent as a user, even if you're in a different environment. So let's say I'm on my work computer, I sign in. I sign into a site with Google Plus Sign-In. Fine. I go home, another computer. I've never signed into this site with it. I open the site up, I should be signed in, because I've already consented. Now, the only way we can do that is if we know who the user is, if there's an ambient identity, in the same way there's ambient location from GPS, right? And that's exactly what we have. We have ambient identity on the web and on Android, and we almost have it on iOS. Not quite. It's not quite as easy. On the web, we have a cookie, right? If you're signed in to Google in your browser, if you're signed into Gmail or to YouTube or anywhere you can use your Google profile, then we know who you are. When I access a site, that site can say, hey, there's a user here, have they signed in? And silently, we can check that. We can see, has this user granted access to this application? If they have, we can just sign them in. So even if I come back a year from now, having signed in today, I come back a year later and sign in again, I don't have to press anything. I'm just there. I'm just signed in. No cookies, but I'm just signed in because I've got that ambient identity with Google. Same thing on Android. We have the account manager. The account manager has my Google identity. So when an application starts, even if it's a fresh install, it can say, hey, can I get a sign-in for a user? And the account manager can be used to look up, hey, has this user approved this application? If they have, just sign them in. We don't need to bother the user about this. On iOS, we don't have that ambient identity. We have to switch out to an application. So we switch out to Google+, or we switch out to Chrome, or we switch out to Safari. And then we'll try and do the same thing as far as we can once we've done that switch. But it means the user has to interact with us. So this is a really important point. This is one of the really fundamental viewpoints in sign-in with Google, is that once you do it, you don't want to do it again. Once you do it, you have access. As long as you're requesting the same scopes, the same permissions, it should just work. But we also want to try and speed up other flows where we can, and those are a bit more targeted, like use case by use case. One of the main reasons, in fact, that a lot of people implemented Google+ sign-in was for a feature called Overtheair installs. And that's this. So this is me signing in on Deezer. And I get a consent screen. The consent screen tells me which permissions I'm going to be granting Deezer, where my usage of it is going to be visible, that kind of thing. When I accept that, in the background, the site signs in because there's a JavaScript callback happening. But that window that had the consent dialog, that window was to Google. And that window stays up because Deezer have said, hey, we have an Android app. And the window talking to Google can talk to the Play Store and go, hey, this user, do they have an Android device? Yes. Can their Android device run the Deezer app? Yes. And have they got the Deezer app installed? No. If those things are true, it can display an install dialog. And I can just press install, and that will be installed straight to my phone. Now, the nice thing about these two features together is they enable, but don't require, you to build an experience which is pretty special, I think. Which is you can have it so that a user signs into your site, gets this Android prompt, presses install, walks out the door, and then, halfway down the street, pulls their phone out, the app is there. They tap the app, and they continue what they were doing. They don't have to sign in again, because seamless sign-in. They don't have to download the app, because Overtheair install. And then you just need to store some state on your server, and they can carry on. Not everyone does this. It's a bit of engineering work, but it can provide just a vastly better experience, I think, and a vastly faster one. Once you've had the user signed in, you don't want to go through that hassle of having to present it to them again. I also think that Google+ sign-in can help make your applications better. It can't make your applications better. We can't make your applications better, but we can give you tools that hopefully will allow you to do some interesting stuff. I'll give you some examples of this. This is OpenTable, which is a restaurant booking application in the US. And they're using a thing called interactive posts, which have two reasonably interesting features. The first one is that there's this button on there, the View Menu button. This button appears in the Google+ app, or it appears on the Google+ site, and when you click it, it takes the user to a deep link into the site. There's nothing technically interesting about that. What's interesting about that is from a user experience point of view, you're pressing a button. So you can do things on that button press. For the user, it feels like interacting. So for example, the fancy user, if you press buy, it'll just add it to your basket. It doesn't take any permanent action, but it just makes that whole process feel a bit quicker. What's really interesting, though, is that for this kind of case, where you're targeting individual people, when you do a share, when you share onto Google Plus and you target those people, that will cause a notification. And that notification will appear anywhere there's the Google Plus Android app, the Google Plus iOS app, or any Google property up in the top there. Actually, this screenshot's a little bit out of date now, but the notification bar is still there. And you're going to get that notification. The user will receive that notification wherever they are. So this is kind of a cheap way of getting notifications out to a lot of people. You don't have to worry about the delivery of it. You just have to allow your users to share and encourage them to share in a targeted way. But that's not all that does. When you share and you include a button like that and you include a deep link like that, you also have the ability to go straight to the matching application. So mostly this is straightforward, right? I can pass a deep link ID that is in parallel with the URL. If there's an application for that platform, then when I click that link, it will open the application and pass that deep link. This is nothing particularly special, I'm sure, to most of you building on Android, because you could do the same kind of thing with an intent filter. On iOS, it's a little bit different. It's a little bit more unusual, but it's still not crazy. The bit that's extra, that's quite nice, is that if you do this and the user doesn't have the application installed, we will take them off to the Play Store or we will take them off to the Apple App Store and let them install it, and then we'll try and deep link them afterwards. So we'll try and really continue that flow and get them into that same experience. And because you can pass that deep link as an arbitrary string, you can really put in state. You can really get it so that the user that's receiving sees the same thing as the user that's sending. That's a cool experience. It makes it a little bit nicer, a little bit smoother. There's also features in Google Plus like app activities. App activities are ways of writing back what a user is doing on your application to Google. And when you do that, that is going to be presented to the people the user has decided to make it visible to. So on that consent screen, there was a little circle chooser. We make it so that users can choose who can see the activities that get written back for them. But we also do stuff with them on aggregate, where there's no user identifiable. There's not that many places where they appear right now. We're just sort of rolling it out in different places. You'll see some more coming, I think, this year. But the first place it ended up was actually in search. So you can see here SoundCloud. They have this little box on search. And they have that box because they have an active Google Plus presence. But the main bit of this box, the middle bit, it says popular with Google Plus users, this is driven by those app activities. This is driven by the users writing those moments, those things that happen, back via the SoundCloud app. And so we can just aggregate them up. And they've marked up those pages with schema.org markup to indicate that they're music recordings, who the artist was, all that kind of thing. So we can pull that data out and we can make that display. And this is cool, right? This is an example of where we can try and expose what users are doing in your applications to other users that might care about that. But these are Google Plus features. These are part of the Google Plus platform. And when you do sign-in, you're doing OAuth 2. And you can request any OAuth 2 scopes. You can attach any Google API. And this is where I think it really gets interesting. You can do basic things, as in the things the APIs were obviously intended for, such as Jolly Cloud. They've got a great example. When you sign in on the web, you sign in with Google+. But at the same time, you can choose to allow access to your Drive or to your YouTube or Picasa or multiple, and then they can pick up on that. Then they can go away and they can access and index that information and make it available through their product, which is a kind of cloud searchy viewer. So that works really nicely. And this kind of thing is, it's a good basic. Hey, I'm going to write some files somewhere. I could use Drive. I'm going to upload some videos. I should use YouTube. Those kind of obvious things are worth doing. If your product does either of those things, then ask for the permission. All you have to do is request the extra scope, and the user gets to consent to it. Sometimes there are things that make life easier. The games service, I think, is a large part of this. This is, for the Google Play Games services, the guys that run that did a code lab, and I played with it. And they've got a little sort of Pong app on Android and iOS. Very simple to set up. When I signed in, I played it badly and got a score of 1 on Android. I signed in on iOS, and my score was maintained. And that was because of a feature called Cloud Save. And Cloud Save is not a hard feature to write. I mean, like the basics of I want to store some data in an API and get it back, anyone in this room could write that. But writing it so you can handle conflicts, that's a bit more work. And writing it so that there are nice APIs on Android and iOS and the web, that's a bit more work. And making sure it's maintained and secure and backed up, it's a bit more work. It's still not that much. I mean, it's still something you could do. It just becomes a bit more of a project. The point is you don't have to. You don't have to build achievements or leaderboards or cloud save or multiplayer matching because they're available by just requesting a scope. You just have to request access and you can tap in to the game service. That's very cool. That saves you time and it lets you focus on your game, which is what you want to be focusing on, not the stuff around it. But you don't just have to use one of these APIs or just use them as you might expect. This little code lab actually does something interesting, which is when I get more than 3 balls bouncing around the screen at the same time, it will record it, and it will upload the video of that to YouTube. And that's not hard to do either. Actually recording an MP4 on either Android or iOS is fairly straightforward. Taking screenshots, even easier. And once you have those, you can upload them. You could upload it to Drive, you could attach it to a Google Plus share, or you could upload a video to YouTube. And at this point, again, I just needed to request that extra scope, that ability to upload to YouTube, and now I can put a video of my gameplay up there. And this is a great way of introducing new users. Users that you wouldn't normally have talked to will now get to see the gameplay. And this has worked really, really well. You see it in a lot of popular Android games in particular, I've noticed, are doing this, where they are allowing you to upload replays to YouTube. And it's a great way of getting exposure for your game. But YouTube doesn't just have to be used for things like this, right? For video uploads, that's the obvious case, but there's tons of data in YouTube that you can get if you just request access. So I had a little sample that I wrote a little while back, which all it's doing is just requesting access to view, not even to write to my YouTube account, just to view. And that allows me to look at things like my watch history, look at the videos which I've liked, look at which channels I've subscribed to. And that's a lot of valuable information. Like here, all I'm doing is retrieving out of my likes playlist all of the videos in the music category, which is a pretty good proxy for music videos. So I can go, if I was building a music listening app, I could retrieve that and I'd have a great list of search terms to plug into some playlist generator, to plug into some search engine, to default for the user. I could give the user a tailored experience when it was the very first time they'd entered my app. That's cool, right? It's one extra scope, and now I have access to this information. Drive as well. You don't just have to use it to upload files and to save things. I mean, I've seen some cool uses of that. Where is that? For example, going in, buy an ebook, well, you can just save the ebook to Drive. You don't even have to download it, which is quite nice. But Drive has a feature called AppData. And AppData is just a folder. It's a Drive folder. But it's a Drive folder the user can't edit. They can delete it because it's their space, but they can't edit it. So if you're building an application which has, I don't know, clients but no backend, and you want servers, but you don't want to stand those servers up, you don't want to back them up and maintain them and all that, you just need somewhere to store some config, you can just request the Drive AppData scope. And here I've got a little form that's on Chrome on desktop and Chrome on Android. And I filled in the form in one, saved it, loaded the page for the first time on Android, signed in, and I had that form data. Right. It's not complicated. It's just some JSON being written to a file. But I can get that file on any platform where I have the identity. It's a clear reason for the user to sign in, and it means I don't have to worry about servers. And this works on every platform. So this is the consent dialog for that on iOS. And I know it's a little bit blurry, but at the bottom you can kind of see view and manage its own configuration data in your Google Drive. That's the scope. It's a specific scope. It's not saying I'm going to have access to all of your Google Drive, just to manage its own config. And you can see in the Manage Apps section in Drive, that's the space it takes up. So as a user, if some app's going crazy and using 10 gig of my Google Drive or whatever, I can go and delete it. But most of the time, I'm just going to leave it. So hopefully that's given you some ideas about why sign-in can be used to do some things beyond just giving you an identity, and why I think it's just a really valuable thing to put into your application. And kind of for the second half of the talk, I want to go into, okay, how do you actually add sign-in? So what are the considerations? And I think there are three considerations when you're adding sign-in. First is, how do you present it to the user? Where's the button go? How do you actually give users a sign-in option? 2, how do you deal with having a server and a client? And 3, how do you actually write the client-side code? And we'll go through those in turn, really. So when it comes to putting the sign-in button up, you might not think there's much to think about here, but I think it's really important. This can be the difference between sign-in and your application working and it just being a bit disappointing, or it just being something the users don't use. And there seem to be about 4 different key ways that users use, that users interact with and that developers use to build sign-in. And the first one is this roadblock. Very, very common on mobile. Sure, most of you have seen this. You start the app, first thing it does is say sign in. This is really easy from a developer perspective. You don't have to care about a user who isn't signed in. There's no worries about it. You know who a user is always, and that's valuable. It's also fast. You don't have to code 2 different paths to care about anonymous and signed in users. But it's not very user-friendly. When you're doing this, you're saying, give me your identity right now. And really, they have no reason to do so. They have to guess whether it's worth signing into your application. They don't know why they're going to be asked for permissions. They don't know why you're going to do this. They just are being asked. Now, you have a little bit of opportunity on the Play Store install page or the App Store install page to actually tell people something about your app, which is why this thing is common on mobile but rare on the web. Because on the web, this is the first place that you'll see it. You'll just close the window, right? So what some people do to give users an option is put an escape route in, put a skip button. And that works. You can go and you can build an application like this. This will recapture some of those users that would have just uninstalled or closed the app. Giving them a skip button is a legitimate move, and it still prompts them to sign in very strongly. But you are going to have to deal with the extra cost of being able to build your application for an identity and for not having an identity. And some users will still uninstall. Some users are just going to look at this and go, oh, I don't want to sign in, go away. So the other 2 options really are where you have the signed out experience as pretty much the default. I go to the application and I am signed out. And the first thing you can do is just offer a sign-in button where it makes sense. So 9gag do this really nicely. They have the sign-in button at the top, and that works. It's just at the top of the stream. Every user's going to see it. It's going to prompt them, but they don't have to. And that's a nice way of making it available without just pushing it in the user's face. The problem with this approach is that sometimes it can indicate that there is a lack of reason for the user to sign in. Sometimes it can mean that you haven't really got a clear view of what the benefit is for the user. And there should always be a strong benefit for the user. This should be a sensible exchange. They tell you who they are, and you make the experience better for them. So sometimes this can indicate there's a bit of a lack of that. And so my favorite way, doesn't work for everyone, so this isn't going to be a panacea, but if it works for you, I think it's the best way, is to actually make signing contextual on user action. So PixArt do this nicely. PixArt, if you haven't tried it, is an image manipulation app. Take a photo, apply filters and stickers and all that kind of thing, and then you could, say, upload it to PixArt, or you could maybe go in to try and buy a sticker pack or whatever. When you take those actions which clearly require the app to know who you are, then it asks you to sign in. And this is a nice experience for the user. They're being asked within context, and so you don't have to explain to them, why should I be doing this? So that's the 4 main options for putting the sign-in button up. But once the user has signed in, most of us these days are using some kind of client and server environment. We have our own APIs which are feeding data, application-specific data, back to our app. And so we need to share that identity to our server. There are 2 primary ways of doing this. It varies a bit. There's a third, but the 2 primary ways of doing this with Google+ sign-in are using an ID token and using a code. And my preferred option is using the ID token. So this is about keeping things separate. You make your calls to the Google APIs in your client, and then you make the calls to your application data from client to your app server. And you don't really try and mix the two. If data needs to be got from a Google API to your app server, the client makes the request and then makes an app-specific call. But we still need to identify the actual user to the app server. Now, if you think about how this is done with username and password, you pass through a username and password, the app server looks it up, and it passes back a cookie. That's exactly how we can do it here. But instead of passing a username and password, we can use something called an ID token. And an ID token is a secure assertion of identity. It's part of something called the OpenID Connect spec. And it looks like this. It's the thing on the top there. What it actually is base64 encoded JSON. It's friendly to put in URLs. It's relatively short, so you can pass it over easily. It is something that is secure, so you should only pass it over HTTPS. But this allows you to verify that the data inside it is accurate. And the data inside it tells you which application it was issued to, who the user is, and who issued it. So the three parts of this token there, the first part is a header that just says, how was this signed? The middle part is the payload, which is displayed there. And the last part is a signature. And the signature can be verified against the public Google certificates. So you can go ahead and check that that information was created by Google. And once you know it was created by Google, you can trust what's in it. So you can trust that the user of your application, as identified by the AUD field there, the audience field, the user of your application is this user, as identified by the sub field, the subject. And that is the Google user ID. Now, if the user had granted you access to their email address, which is just another scope, if they granted you access to their email address, that would be in here as well. So you can pass across this token to your server. The server doesn't have to make any network calls other than occasionally refetching the Google certificates, but can take that, verify the Google user ID and the email address of the user that is connected to your client. So you can then return a cookie, set up a session, and you can make API calls securely. CheckIn is very easy. There is some crypto involved, so it's best to use one of our client libraries. This is the Java client library. You see it's really straightforward. There's just a checker object. We can pass it that token, and it's going to go ahead and check to see whether the certificate matches. We can check to see whether the client ID matches, so it's for the application we expect it to be for. We check whether it's expired and that kind of thing. So we can pull all those checks together, and if they're okay, return the Google user ID. And with that user ID, we can just look it up in an application database. So normally, the flow would be send an ID token over, server goes, check it's valid, it is, look up this user ID, is there a user for it? If there is, cool. Return a session, return whatever data was requested. If there isn't, then create a user, or maybe respond to the client and say, hey, you've got to go through a registration step, or you've got to get some extra data for this person, and trigger whatever flows you'd need for a new user. Actually retrieving the token is super easy. On iOS, you can just get it any time the user signed in. GPP sign-in shared instance is a kind of singleton object that is universally available in your iOS app. Once the user's signed in, it's going to be populated with all sorts of information, including an ID token. And on Android, you have to use a thing called Google Auth And Google Auth is the Google Play Services identity layer. And the thing we'll look at a bit later, Plus Client, which is how you do Google Plus sign-in, is kind of built on top of it. So Plus Client is like a friendly layer on top of Google Auth So with that, once you've signed in, you can very easily pull out the account name of the currently signed in user, and you can call this Google Auth get token function. It may cause network traffic, so you have to do it in an async task, but it's hardly any code. So the second way of actually doing sign-in is with the server, is if the server needs to make API calls. Most of the time, as I said, I prefer the other option. But there are legitimate reasons you need this. For example, if you are making calls to do something when the user is not using your client, for example, you're uploading large files to their drive or YouTube, or you're scanning their mail for attachments, or you are doing background checking of their contacts or people they have in circles, that kind of thing. If you're building that kind of experience, then you'll need to have access when the server's not there. Unfortunately, on iOS, this is tricky right now. We don't have a good solution for this because you can't get this code that's passed around. There's some workarounds, but it's problematic, and it's something that we're looking at. But on Android, this is relatively straightforward. We can get a code, and we can send that across to the server. The server can then exchange that code, and it'll get back an access token, an ID token, and a refresh token. And the refresh token lives forever. It is a token which you put in your database, you keep very secure, but you can use at any point to get new access tokens. So even when the user has not been back to your app in months, you can go away, get an access token, and make calls to them, which is convenient if you need that. You see here, we're actually using the same method as before, this Google Auth util. This is actually overloaded to let you get access tokens and ID tokens and codes. The difference is when you will have to resolve errors on it. With a code, to get a refresh token, the user must have seen a consent dialog, which means if you call this in the normal flow of a sign-in, you will get a user recoverable error back, which when you resolve it is going to require displaying an intent. It's going to give them a account user and maybe a consent dialog, that kind of thing. That consent dialog has to be seen within a short time of you retrieving this code, or you can't do it, which means you don't want to do this as part of your normal flow. In fact, the flow you probably want is check with the ID token, does the server already have a refresh token? If they don't, then use this method. Then get the code and show the user a consent screen. So that's the two primary ways of getting the server authenticated. To actually implement sign-in on the client, you need to make a project. So you've seen the mention of the client ID. That was the audience field in the ID token. That's referring to a client that is part of a project on this console, on the cloud console, or the API console, developer console. It's had a few names and a few iterations. This is where you configure which APIs are available, and it's where you configure all of the different clients of your app. So your app may have an Android client and a pro Android client, which is pay, and a iOS app, and a web app, and a device, a smart TV or something. So you may have multiple clients for your application, and they should be within one project. A lot of the stuff we've talked about, like seamless sign-in, works between clients of one project. So it's important to make sure they're in the same place. And it's important to enable the APIs you want to access. It's not enough to just ask for the scope. You've got to turn on the API. This is also where you can manage things like quotas. So if you're doing some calls on some Google APIs, you'll find there are limits on how many calls you can do per day. You can normally request more quotas, or for some APIs, like translation, you can turn on billing to allow you to pay for more calls if you want them. So, sign in on Android. Pretty straightforward. And you're going to see this flow again. I'm not going to cover web here, but if you want to look at the web flow, you'll find it's actually got the same dynamic. And the dynamic is that we want to see whether the user is signed in. If they are signed in, great. If they're not signed in, we have to show them a button and then interact with them. And because sign-in is implemented through Google Play Services, we need to do that by connecting to Google Play Services. So we have a Plus client, which is really, it's like it's iBinding to a service, right? It's not a complex thing. And we do that usually in a base activity or in a fragment that we attach to our activities. And the reason we want to do it somewhere like that, somewhere that's throughout the app, is because we want to do this test to see if the user is signed in wherever we are. We don't want to just do it on a login screen because we want that seamless sign-in to happen. So the first screen the user gets to in the app should be able to test whether they're signed in and respond appropriately. So they don't have to press that button. They don't even have to see that button if they don't need it. So when we start our activity, we can connect to Google Play Services with a Plus Client Connect. If it fails, so if the user has not signed in or we're asking for more scopes, we will get a on connection failed callback, and with that we'll get a connection result, which we'll store. We don't do anything with it at that point. We only do something with it when the user presses the sign in button. So we know when we get that callback, we're in an anonymous state, and we can do whatever we need to. When the user presses the sign in button, we then resolve the error on that connection result. That's going to give us basically wrapping a pending intent. That is going to fire. The user's going to either choose an account or consent or both. And then we're going to get an on-activity result callback. And all we do is start the flow again. We just call connect again, and hopefully all the errors have been resolved, and we go straight to on-connected. If not, like, for example, the user cancelled, then we'll go back to on-connection failed. So we need to create a client in our console for this. I'm sure most of you have seen an Android client ID before, but if you haven't, note there are two things in it. There is the package name, and that package identifier is just your regular com.example.myapp. And that is used for identifying the application, for doing the deep linking installs to the Play Store, that kind of stuff. And the fingerprint of the signing key. It's really important to do both your one client ID for your debug fingerprint and one for your production one. I've seen at least one app almost go live without having a client ID, which would not have resulted in a good user experience. So be sure to add a separate client ID for your production key as well. This pairing has to be unique. So there can only be one client ID that has, oh dear. Well, there can only be one client ID that has that mix of the signing key and the package name. And if you do want to create, multiple apps with the same signing key, that's totally fine. They can be in separate projects, separate clients. So if your company makes 4 different apps and you have a free and a paid version of each, you'd have 4 different projects, and each one would have 2 Android clients. Well, probably they'd have more than 2 Android clients because you'd have debug and pro keys. I normally use Gradle for setting up the actual dependencies on this. So the way that I would go and implement this stuff is just by adding a line to my Gradle config. If you are implementing Google+ Sign-In and you want to use a library, and you want to use it in Eclipse, you can just import the Google Play Services client as a library project. So that's actually pretty well documented. The Gradle version is just easier. So if you're using Android Studio, I'd definitely use that. So I'll try and give you an idea for what the code would look like. I could do it with MIME. I don't know. So there is fundamentally a class called +client, right? And +client is the heart of the Google+ part of Google Play Services. +client, you configure it with all of the data about your application. So you configure it with the scopes you're going to request. So like if you wanted YouTube, you'd add the YouTube scope. If you wanted Drive, you'd add the Drive scope and that kind of thing. You give it the information of which kind of app activities you'd like to write, like SoundCloud. And once that information is there, then you will get an actual +client back off the builder. The builder doesn't do anything. So when I create a +client, nothing happens. No attempt to make a connection occurs. All that happens is I get back the object. So that's why I need to connect it. We'll normally do that in your activities on start, and we'll disconnect in the on stop. There is a cost to keeping that connection around. It's the same as keeping normal service bindings around. It can block GC. It's got a little bit of overhead. So you generally want to connect and disconnect with your activity lifecycle rather than your app lifecycle. Once you've done that connect, that will always attempt to see if the user's signed in. If the user isn't signed in, you will get the on-connection failed callback. If they are signed in, you're going to get the on-connected callback. So you're going to get the callbacks back into your activity, whatever happens. That doesn't trigger any UI. So you do that every time. No UI happens. Like I said, you just get that connection result object, which wraps a pending intent. When you call resolve, it's going to display the activity. The subtleties around using +client tend to come in the fact that you have to consider the flow of the sign-in process, particularly when you're using it with other applications. So if you're using it with an ID token, you want to send the ID token to the server, you want to make sure you only do that once you get to the onConnected. You don't try and retrieve it beforehand. If you want to make calls to other APIs that aren't in Google Play services, then you can get a token out of it and you can pass that to the standard Google client libraries. So it's all pretty straightforward to work with. It just is very asynchronous. It's a flow that is happening with a lot of callbacks to get through it. iOS is actually pretty much the same way. So iOS, we can't do sign-in based on a service. Aha, we have some slides. So this is the on connection failed. I'm going to point out, we really don't do anything with it there. That really is just storing that connection result. But it's important to store that connection result. You might think, I can just call something else to bring up the consent dialog, but that connection result is kind of temporary. If, for example, your activity gets restarted because if the phone gets rotated, that connection result will change. So you always want to have the latest one there to actually use in your resolution. And when we click it, it is really just start resolution for result. It's very, very straightforward. Let's see what we got. Oh yeah, one last bit, just the on-activity result. Again, just to make clear, this on-activity result is at the end of that process. All we're doing is reconnecting. We don't do anything. We don't actually look at that result at all, because all it says to us is that the flow has completed. And if you implement more complex flows, for example, if you're doing the code flow from Android, you'll see that that is a very common pattern. Whenever you're thinking about dealing with Plus Client or any of the authenticated Google Play Services clients, so Google Play Games, Wallet, that kind of thing, you always want to be kind of setting your flows up so they trigger a connect at the end. And then you're into that very easy state. You either get on connected or you get on connection failed. So it makes life easier to track. iOS. On iOS, we've got broadly the same flow. But it's simplified for us as developers because a lot of it actually happens somewhere else. So on iOS, we always start with a thing called tri-silent authentication. And just like the Plus Client Connect, we want to do this everywhere. This is the check, have we already authenticated on this device? And if we have, then we're going to get a callback, finished with auth error, and the error will be nil. We know that we're good to go. If we haven't, then it's going to return false, or we'll get a callback to finish with auth and error won't be nil. And at that point, we want to display a button. So same plan. Are we signed in? If not, display a button. And the display, once the user actually clicks it, we're going to call GPP sign and authenticate. Now, I want to make clear that when I say display a button, that doesn't mean you actually have to, put something up in the user's face. It could be, when I say display a button, it means actually in a settings page, you display the button. The button doesn't have to be connected to where the user is at the time you check. It just means that is the point at which you know the user is not authenticated. So when they click, we have to sign them in. And to do that, we take them out to the Google Plus app, or we take them out to Chrome, or we take them out to Safari. And we do it in that order, so we prefer it in that way. And as far as possible, we want to go to somewhere where the user is already signed in. We want them actually entering their Google username and password to be the worst case, the least likely case. And that's pretty much how it works out. We need a client ID again. Now, it's a little bit different from the Android one. We got two parameters again, and we got the bundle ID, which is pretty analogous to the app package name, doing roughly the same job. But we also have the App Store ID. And when we do those deep link installs, that's the ID that it uses to actually go and take the user to the App Store and let them install the app. The bundle ID does double duty, though. We're not just identifying the application, we're also going to use that to make callbacks to the application. So iOS doesn't have something as nice as the intents model, but it does have custom URLs. And that's how we can do calls between applications. But it means that we need to have a known URL for each application using Google Plus Sign-In that we can call back to. So when we call for a deep link, we have to call to a URL. When we return the user from signing in, we have to call to a URL. And that URL has to match your bundle ID. So whatever gets defined in here, we need to set up as a custom URL type in Xcode or in your info.plist to say, I am going to handle responses of this type. And after that, that's it. You don't have to worry about the rest of it. It's handled automatically. Now, once you've done that, you need to include some dependencies. there's 3 dependencies in here. There's the Google Plus framework, Google open source framework, and the Google Plus bundle, which is basically what's in the Google Plus iOS SDK. This is what's going to, this is our bit of code that we're giving to you. The rest of this here are system bundles. And if you've implemented Google Plus Sign on iOS before, you might notice there's a few more. The reason for that is we now have a native share box. So we have a share box that actually is in the application, doesn't take the user away, allows you to attach images, allows you to attach videos and interactive posts and all that kind of thing. So it's a lot nicer, but it does require a few more system frameworks. How we actually implement on iOS is pretty straightforward. We need to tell it our client ID, so we don't have that automatic detection of the client ID based on the sign-in key and the package name like on Android, so we have to specifically tell the app what the client ID is. And we can configure all of those other basic parameters, so like scopes, so like which app activities we're going to write, that kind of thing. We can also tell it to do some stuff for us. So there's a flag here for, say, hey, go and get the email address. There's a flag here for, please automatically get the user's profile, which is this should fetch Google Plus user. And that's just basic configuration. Once we've done that, we can call the try-silent authentication method. And the try-silent authentication method will return true or false, or yes or no, depending on whether there is a token stored in the keychain for that application. If no, the user is definitely signed out. If yes, they're probably signed in, but it could be that they've revoked access on Google+, or they've actually disconnected the token from the other side. So when we get a no, we know we're going to have to show a button, and when the user clicks that button, wherever in the app it happens, we're going to call that GPP sign-in shared instance authenticate. Because we configured everything against that singleton, that's got all the appropriate config and will be called. When the user will be taken out, say, to Google+, they'll choose their account, they'll consent, and then they'll come back to the application. And when they come back to the application, we'll get a call into the application open URL function, just a standard app delegate function, and we can use this little GPP URL handler that's going to also deal with deep links and other kinds of URL, and will eventually take us through to this finished with auth error. And finished with auth error, very simple callback. All we need to do is check, is error nil? If it's nil, we're good to go. We can send the ID token, we can personalize whatever we need to do. If it's not nil, then usually what happened is the user was cancelled. That's the most common reason for the error being nil. And you might actually want to do something in that case. If the user cancels, maybe it's because you're asking for too many scopes. So you might want to then pop up a scope chooser and say, hey, would you like to sign in just with Google+, or would you like to sign in without access to your drive or to whatever you think they might be worried about? But there are cases where it could be something else. For example, if you had signed into that app previously and then disconnected through the Google Plus apps page, which most users are very unlikely to do, but developers do quite a lot. So you're much, much more likely to run into this than normal people. So that's pretty much it. That gets you to the end of the flow. That gets you signed in, you have an access token, you can make calls to the Google APIs, you can send ID tokens to your server. You're done on both platforms. If you want to see us in a bit more detail, on developers.google.com/plus, there are sample apps. There are sample apps on Android and iOS and pretty much every server-side language we could get going. So there's a good 8 or 9 languages in there. And they will show you really how to use this stuff sort of in anger. There's also a quite complete application called Photo Hunt you can try, and there's tons of documentation. If you're interested in any of the other APIs, like apps or games or Drive or YouTube or anything else, they're pretty much all under developers.google.com/product. So /drive/games/service, actually. And you can find anything about them there. Most of those also have samples in Android and iOS and most of the client-side languages. So hopefully you should be able to get any extra information that you need. So that's about it from me. Thank you very much and for dealing with a brief time without slides. Does anyone have any questions? I may not notice you if you do, so shout at me. Okay, cool. Thank you.